Yes, good afternoon everyone. I welcome you all. It's a great pleasure for me introducing today's section 2 resource person, Dr. Pooja Jain, Assistant Professor, Department of CSE, IIIT Nagpur. Welcome ma'am. I would like to request Dr. Neeta Thakke ma'am to welcome Dr. Pooja Jain with the sound. Dr. Pooja Jain is currently working with Indian Institute of Information Technology, Nagpur, in the Department of Computer Science and Engineering. She has close to 16 years of experience in industry as well as academia. She has worked with multinational like IBM and CSE. She has conducted 6 federal FDP and has been an expert in more than 50 workshops and keynote in many conferences. Currently, she has 5 PhD scholars working under her guidance. She has also project with DRDO. Welcome, ma'am. I request Dr. Pooja Jain, ma'am, to proceed for the session.
Thank you for the introduction. कैमरे के आगे
पार्टिसिपेंट मैंने नहीं किया फॉर्म इन उसके बाद कुछ न्यूमेरिक नंबर्स है तो फॉर्म इन जो है ईआरपी आईडी का यूजर आईडी है और 011220223 ये पासवर्ड है तो इनके पास ईआरपी आईडी नहीं है किसी के लिए
वो जो आ रहा है ऑथेंटिकेशन वाला इसमें लॉगिन करना
इंटरनेट एक्सेस कर सकते हो आप तो अभी रिक्वायरमेंट नहीं है
we would require it. Okay, so thank you so much. Thank you, Neeta ma'am, especially for giving me this opportunity to have an interaction with all the members here. Thank you so much once again. The introduction was already there for me, so nothing to be told about myself. First and the foremost, I would like to know that what is your comfort zone in machine learning so that I can proceed further accordingly. That is, have you been introduced to machine learning ever? So what is the level of comfort that you have in machine learning? You know what is supervised and unsupervised algorithms? Every one of you? Yes?
Yes, ma'am.
Okay. So any particular algorithm on which you have worked on? No. You haven't done the implementation of those algorithms, is it? But you know, you have a fair idea what is a supervised algorithm. So can any one of you tell me just what is the difference between a supervised and an unsupervised algorithm?
in supervised we use labeled data.
Mm-hmm.
In unsupervised we use unlabeled.
Unlabeled data. So that is the only difference or something else apart from that?
For some small data set we can have small data set we can have supervised learning.
Okay, and what is the definition of small?
Not in terabytes.
In supervised learning, when we know the output, in unsupervised learning, we are not aware of
Okay. So any examples for supervised learning algorithms?
regression algorithm,
Okay.
Classification.
Classification algorithms. So all the regression and the classification algorithms lie in supervised learning. And in unsupervised learning, any examples? Clustering. So when you say that you don't know the output in unsupervised learning algorithms, so what is the concept of clustering then?
Just on the basis of similarities, they used to make out the group of the data points in the network. So
So the number of clusters are known A priori?
Yeah, of course that is also a priority, how many number of clusters could be there, but actual scenario.
So if the number of clusters are known, then in a sense you know the output as well?
No.
So based on the similarity, we are calculating like distance similarity.
If we change the clustering, the output will also be different.
Okay. The output would be different if you change the clusters.
Number
The
of
number of clusters.
Okay, so if the number of clusters are changed,
Sender one will change from the different cluster, then obviously the output will be changed.
perfect. So I believe that you have a fair idea of supervised and unsupervised algorithms, and you're also aware of what is regression.
it's
It requires the continuous data. It requires continuous data. I mean, categorical data. If we have, then we can apply the regression.
Categorical data, we go for regression.
Categorical, we go for the classification.
Yes.
yeah,
Yes. So if you have a continuous data, we go for regression, and if you have a categorical data, we go for classification. So continuous data means if I have something as I have these points and I want to draw a trend. So if I draw a straight line, then this is linear regression. Correct? If I go something like this, then what will it be called? It's not linear, of course. I'm there. I'm visible in the camera. If I go as this, then what will it be called? Polynomial. What is the equation for linear regression? Y is equal to mx plus c. Very good. So if this is y is equal to mx plus c, which is the equation of the simple line, that is a trend line that I am going to follow. Y is equal to mx plus c is the equation of the line. If it is when I have only one parameter, correct? X is only one parameter. If I have more than one parameters, then
Polynomial regression.
that will be known as polynomial regression.
No, we not.
Is it okay?
More than one parameter.
Multiple linear regression. So we call it as multiple linear regression. If I have many parameters as x1, x2, x3, x4 and so on till xn, then we call it as multiple linear regression only if I am going for a straight line. So the equation for this would be very simple. Y is equal to, I may have the coefficients now. As we have a coefficient m here, similarly I will have the coefficient as theta naught, or you can say theta 1 x1 plus theta 2 x2 plus so on till theta n xn plus theta naught. This theta naught is the same as we write it over here as c. Correct? And we have theta 1 x1, theta 2 x2 and so on. This is multiple because we have multiple parameters. x1, x2, x3, x4, they are multiple parameters. Multiple linear regression. What is polynomial regression? Polynomial regression? Yes, if we have the powers, we say it is as a polynomial regression. So if I start having the powers here, so then it will not be a straight line, but it would be a curve. So generally, when we go for a linear regression, we don't get very good results because we are forced to have a straight line. And when we go for a straight line, of course, it may happen that some of the points are very far off, and what will happen if the points are very far off from the straight line, from the trend line, a line of regression?
Outlier. Problem of
Outlier is very far off. This is an outlier, but I am saying that these points are a little far off from the line of regression.
underfitting problem.
No.
Error term.
Loss.
Loss.
So we call it as error, loss, or cost. All the three are the same words in which the meaning of everything is same: error, cost, or loss. In which I am trying to find out the distance of each and every point from this. Okay? So if I have this trend line or line of regression here, and I have these points. So I will try to find out the loss. If this is x1 y1, this point was x1 y1, which is lying on the x is same. X is same. Only the y is changing. We call it as y predicted. Because that is the point where I am predicting it. Correct? Similarly, suppose this is the point which is x2, y2, and I am predicting it to be here. So if I try to have the distance here, correct? So I am predicting it to be here. So although it was y2, but I am predicting it to be here. So my prediction minus actual is my loss, cost or error. Clear? If I want to combine the loss of each and every point, then how we say that is known as RMSE. You must have heard this one. RMSE. Root means square error. ठीक है? इसको चलते हैं उल्टा है लेके. So first we calculate the error, we square it, we take the mean, and then we take the root. ठीक है ना? Error क्या है मेरा? YP minus YA. मेरा error है predicted minus actual. ठीक है ना? यहाँ पे भी कोई point था. x1 y1 मेरा point था, and I said keep this line at this particular point. That is, there is some error. It was supposed to be here, but I am saying no, it is here. Clear? So YP minus YA was the error. Square of that error, mean of that error, I is equal to 1 to n, and I put a I here. So for the first point, second point, third point, fourth point, fifth point, etc. till n points, and then I take the square. This is the RMS. Easy? Okay, so YP minus YA, that is the y predicted minus y actual. You calculate the RMSE for it. RMSE means error, square, mean, root. आप उल्टा कैलकुलेट करोगे और आपका ये RMSE का फॉर्मूला है. ठीक? So when I am saying that my points are very far off, so that means my RMSE is very large. My error is very large because my error terms, my cost terms, my loss terms are very large. So I need to reduce that, and that is what machine learning is all about. That is, I want to have my YP in such a manner so that my YP minus YA is minimum. My loss is minimum. And this we do it in each and every algorithm. Whether you call it as supervised, or unsupervised, or anything. The basic concept lies is that I want to predict my data in such a manner so that it is very much similar to actual. What is machine learning? If I ask you what is machine learning?
Machine learning is a part of AI growing technology that enables machines to learn from the past data and execute the task automatically.
Very good. So it is learning from the past data and it is doing the things automatically. Correct? Are you also learning? How do you learn? Apart from bookish knowledge or apart from the workshop that we are having? Any example that you learn? Experience. So experience is known as learning? Yes? Every minute you are having some or the other experience and you are learning out of it? Clear? So if something similar happens in the future, you say, अरे पहले वो किया था तो अब भी यही करेंगे. अगर आपको बगल में भी जाना है, suppose I have to go to IIIT Nagpur. You have to go to IIIT Nagpur and I followed path A. There are 3 paths. This is my source and this is my destination. And there are 3 parts to go, 3 ways to go to this particular location. X, Y, Z, Z dash. Clear? I took this path today and I said that it was बहुत ही बेकार रास्ता था, गड्ढों से भरा हुआ. I will not take the path next time. This is experience. I am learning from it. Yes, I learned from this experience. I said I am not going to follow this path again. It was very bad, so probably I will follow the Y path. Or if I say the Y is taking a lot of time, let's try a new path. I will go to the Z path. Z path was better, it took less time and it was lesser distance also, so I took the Z path. So I am learning from my past experiences. Clear? So when I am learning from the past experiences, this is also doing the same thing. When I said कि my y, suppose my x was 2 and my y actual was 4, and I said I predict my y to be as 3. Correct? So my loss was 1, minus 1 or plus 1 whatsoever. It's mod 1 basically. So it's a loss of 1 when I say that my predicted value of y is 3 and my actual was 4. So I learned from it and said that okay, I need to proceed a little on the positive side. Clear? So I say minus 1, so I increase it a little bit and say that okay, now I predict it to be 3.1. My loss is reduced. If I predict it to be 3.2, my loss is further reduced. It will reduce, and at one point of time it will start increasing. Why?
So once it is reached threshold value, and after
What is it called? ऐसा कुछ एक कर्व देखा होगा आप लोगों ने. क्या बोलते हैं उस कर्व को? हाँ? बायस वेरिएंस तो आएगा बाद में. Gradient. Very good. So when I am trying to plot this is the gradient descent. I plot the loss function. So my loss function gradually decreases, keep on decreasing, and at this particular point, as what she said, I reach a threshold. After that it is not possible to reduce it further. That is, I cannot reduce my loss further, so it starts increasing. So if I say this is my optimal rate. This is my optimal result. This is my optimal result. इसके पहले क्या होता है? ये ऑप्टिमल है, तो इसके पहले क्या है? बोला था क्या आपको? अंडरफिटिंग. दिस इज अंडरफिटिंग. और इसके ऊपर क्या हो जाएगा? ओवरफिटिंग. कोई मुझे लेमैन टर्म्स में बता सकता है ओवरफिटिंग क्या होती है? ये अंडरफिटिंग क्या होती है?
That is training error. It is minimized.
लेमैन टर्म्स मुझे एमएल नहीं आता.
Overfitting that means the points are
Insufficient data.
no, more than sufficient, more than required.
इनसफिशिएंट डेटा तो अंडरफिटिंग.
Excess
Model is complex.
Excess learning is to provide it to the model and the data.
मॉडल सब गया बाहर में. ओवरफिटिंग क्या होती है? हैव यू एवर एक्सपीरियंस्ड ओवरफिटिंग?
suppose हमारा
आप लोग अपनी लाइफ में बताओ कभी ओवरफिटिंग एक्सपीरियंस है?
लगेज बैग है, उसकी कैपेसिटी से ओवर हम फीड कर रहे हैं जो हमारा थिंग्स एंड गुड्स है, तो वो होगा
ओवरफिटिंग हो जाएगा वो.
थिंग्स.
ठीक है, हट जाएगा.
ऑब्जेक्ट को अगर मुझे डिफाइन करना है और जहाँ पे मैं जैसे कोई बर्ड है उसको किधर है तो और चोंच होती है तो बेसिक पे डिटेक्ट करके बर्ड पर इसके ज़्यादा अगर हम लोग ले रहे हैं तो डिटेक्शन डिफिकल्ट.
बर्ड के मतलब कुछ और बोलने लगे, शेर बोलने लगे कुछ.
तो मे भी हो सकता है मैं वो डिटेक्ट ना कर पाए तो हो सकता है दैट विल कम.
ओके, एनीथिंग एल्स? आपने कभी ओवरफिटिंग अपनी लाइफ में एक्सपीरियंस करी है? खुद अपने ऊपर नहीं की? बहुत करी है. सोचो, इनफैक्ट हफ्ते में एक बार करते
Which
हैं.
is by heart कर लेना and if the new situation arises.
आप लोग घर जाके कभी नहीं बोलते यार आज कुछ ज्यादा ही हो गया कॉलेज? बोलते हो? बर्डन, आज कुछ ज्यादा ही हो गया. तो व्हाट इज कुछ ज्यादा ही हो गया? कुछ ज्यादा ही हो गया इज ओवरफिटिंग. कुछ ज्यादा ही हो गया. आपने बच्चे आपके छोटे बड़े जो भी मतलब अगर 3rd या 4th क्लास का बच्चा है, ज्यादा पढ़ा दोगे तो स्कूल में सब निपोड़ के आ जाएगा क्योंकि ज्यादा पढ़ लिया है, कंफ्यूजन हो गया. और हिस्ट्री में तो कमाल होता है, अकबर की डेट ऑफ बर्थ बीरबल से मैच हो जाती है. So why this is so? Because I have learned so much that I have confused myself. Coming to what his example is, if I give lots of features of the bird, then it may happen that the model gets confused and it is not able to predict that this is a bird or not. So even if I am giving it the image of a lion and he's saying it is a bird, because I have given him enough features to it, and that is why it has got over confused. तो जब आप कंफ्यूज हो जाते हो करने में, एंड इनफैक्ट जैसे बोला ना वंस इन अ वीक यू ऑलवेज फेस दैट, आई एम कंफ्यूज, आई डोंट नो व्हाट टू डू, तो आप बैठ जाते हो शांति से एक जगह, मुझे कुछ नहीं करना. इट हैपेंस. because I have so many things in my mind going on that I don't want to do anything. Correct? The same thing happens with the model as well. Machine learning, that is why I started by saying what is the definition of machine learning. So if somebody asks you what is machine learning, so you simply say, I'm trying to make my machine behave like me. That's it. I'm trying to make my machine behave like me. If I can learn, the machine can also learn. If I can walk, I want my machine also to walk in a similar manner as I do. If I am able to recognize your faces, then I want my machine also to recognize the faces. And that is nothing but face recognition. Correct? ठीक है ना? So face recognition, and if I ask you ma'am, how do you recognize the face? अब आप मुझे दोबारा देखोगे तो पहचान लोगे?
Yes.
पक्का?
Yes.
कैसे?
Features. Some model has been prepared.
मॉडल यहाँ पे
By sort of.
by features आप पहचान लोगे. And in fact if I ask you कि आपने कभी cat देखी? Generally cat is of which color? Black? Grayish, blackish. अगर एक व्हाइट कलर की कैट निकल जाएगी जिसको आपने कभी नहीं देखा है तो क्या उसको कंफ्यूज कर जाओगे कि ये ज़ीब्रा है? You would be able to find it out कि it is a cat. Even if you have not seen that cat ever in your life, you have not seen a white tiger. ठीक है ना? White tiger आपने normal tigers बहुत देखे हैं, but it's a tiger city. So you have seen lots of normal tigers, but you have not seen a white tiger.
White tiger is there in Bangladesh.
That
Outside.
outlier basically. But if you see a white tiger, you will not confuse it to be a lion. Although both have similar features. A tiger and a lion have similar features, but still you will not confuse that tiger to be a lion. Why? Because we are so intelligent. We are able to identify the features of a tiger as well. अब उसके पास जाके उसके ऊपर चढ़ के तो नहीं देखे थे मैंने उसके features. बट फिर भी हम पहचान लेते हैं. इतनी दूर से टाइगर को देखा होगा जहाँ वो सर बैठे हैं, वहां से टाइगर को देखा होगा, फिर भी हम उनके फीचर्स पहचान लेते हैं, सब कुछ समझ में आ जाता है और दोबारा उस टाइगर को देखेंगे तो हम पहचान लेंगे. Yes, and even if the color is not matching, still I am able to identify that this is a tiger. Correct? So the same thing I want my system also to do. So that is why earlier when we talk about somewhere 15 years back, we used to do this machine learning itself, but my data was fixed. तो हम क्या बोलते थे कि मैंने तुमको व्हाइट टाइगर की भी इमेज दी है और येलो टाइगर की भी इमेज दी है और फिर तुम बताओ कि दिस इज अ टाइगर और नॉट. करेक्ट? So 10-15 years back also we were doing the same thing, and that was data matching. Information retrieval जो हम लोग बोलते थे जिसको. Information retrieval is nothing but I am retrieving the information as what I require, but that information was available in the database. And we were able to take that information from the database, whatever is there. I was not able to make the information at that time. So if I had the image of a white tiger, I was able to identify a white tiger. If I had an image of a yellow tiger, I was able to identify a yellow tiger. But now we have gone one step ahead and saying that even if you don't have a white tiger image, you should be able to identify a white tiger. That is what machine learning is all about. So when she said the definition of machine learning automatically does it. So automatically does it, but even if I am not giving the image as a database, still it can identify that this is a tiger. Okay? So color will not be the only criteria in deciding the image. या image recognition, face recognition. अब सर को देखा, अगर सर का भाई आ जाएगा तो भी हम पहचान लेंगे. अगर सर का भाई आएगा तो हम पहचान लेंगे ना कि आपकी शक्लें मिल रही हैं. ठीक है ना? तो सर की इमेज मुझे मैंने सिस्टम को नहीं दी है. अगर सर के भाई की इमेज देंगे तो वो सिस्टम को पहचान लेना चाहिए कि ये सर नहीं है लेकिन सर के भाई हैं. समझ आई बात? Because we are doing it. We are doing every time. If I say someone कि आपको बहुत देखा हुआ है, तुमने बोला आपने मेरी बहन को देखा, आपने मुझे नहीं देखा. It happens. So I want my system also to do in the similar manner. Whatever I am doing, I want my system also to do the same thing. Correct? So there comes the concept of machine learning, that I am trying my machine to learn the patterns, learn the features in such a way so that if any different image comes in, then also it is able to identify. Correct? So that is where we come the concept of training, testing and evaluation. कोई बता सकता है तीनों में फर्क? ट्रेनिंग, टेस्टिंग एंड इवैल्यूएशन. ट्रेनिंग और टेस्टिंग आपने सुना होगा और इसका आपको मतलब भी पता होगा. क्या होता है ट्रेनिंग और टेस्टिंग?
They would learn from that.
Correct. And then I give a test data and then say that whether you are able to identify it. It's very similar that I have given him the images of tiger and I am just giving a white tiger image and saying that you identify whether it is a tiger or not. Clear? This is training and testing. What is evaluation? Yeah, validation you can say. What is validation?
After testing the data which we got, whether it is accurate or not, that would be
After testing?
means the result which we got after testing.
वैलिडेशन, इवैल्यूएशन बोलते हैं जनरली उसको. मशीन लर्निंग की कौन आपने सारी वो साइकिल पढ़ी होगी कहीं पर, शायद मेरे पास भी होगी, नहीं मेरे पास इस समय नहीं है. मशीन लर्निंग की साइकिल में आप क्या बोलते हो? ऑब्जेक्टिव डिसाइड करना, गैदरिंग द डेटा, प्री प्रोसेसिंग द डेटा, EDA, exploratory data analysis, and then you go for building the model, predict, evaluation and then prediction. तो prediction के पहले आता है evaluation. What is that? What is evaluation? Evaluation of the model.
Whether our approach is correct or not, we do whether we achieve our target or not.
तो वो टेस्टिंग नहीं होता. हाइपर पैरामीटर ट्यूनिंग हम करते हैं ट्रेनिंग के टाइम पे भी और इवैल्यूएशन के टाइम पे भी. दैट इज वैलिडेशन के टाइम पे भी करते हैं.
Sort of introspection, whether we are going on the
Okay, I'll take your point. Good. Introspection is a good word to say. That is, we are trying to find out whether I am going on a right path or not. Okay, I'll give you an example on this. अब आपने ये सब पढ़ लिया, आपका टेस्ट भी होगा ना वर्कशॉप का. वर्कशॉप के जस्ट एक दिन पहले आप लास्ट डे आपका टेस्ट होगा. तो आपने सब कुछ पढ़ा and so you are studying all the things and at the last you have your test. So this is your training period and then you are tested at the last. तो ट्रेनिंग और टेस्टिंग हो गई. बट आपने क्या किया, आपने ट्रेनिंग तो पढ़ी पूरी, सैटरडे को आपका टेस्ट था, फ्राइडे को आपने क्या बोला कि आप दोनों जन साथ में बैठे कि यू आस्क मी सर्टेन क्वेश्चंस कि लेट मी नो वेदर आई हैव अंडरस्टूड और नॉट. दैट यू डू. ठीक है ना. You two will sit together and say that okay, you ask me certain questions and let me check whether I have done it or not. If not, I'll study that. Yes, take this point very very clearly. If not, I'll study that. ठीक है ना. What's your name, ma'am?
Pallavi.
Pallavi ma'am. Shalini ma'am. Okay. So Pallavi ma'am asked certain questions to Shalini ma'am, and Shalini ma'am said that no, I don't know this. Let me study that part on Friday night. ठीक है ना. So what they are doing exactly is they are not being tested as of now. They don't get a test result. They are not getting A grade, A plus grade or B grade at this point of time because the test is on Saturday. Correct? On Friday night they are having a discussion amongst themselves and saying that okay, you ask me certain questions and if I am able to answer those questions, well and good. If not, I will study those questions. This is known as evaluation or you can say validation. ठीक है ना. तो ट्रेनिंग, वैलिडेशन एंड टेस्टिंग. तो वैलिडेशन के टाइम पे व्हाट वी डू इज वी फाइंड आउट द वैलिडेशन. टेस्टिंग भी आपने सुना, वैलिडेशन एक्यूरेसी भी सुना होगा. Validation accuracy and testing accuracy, there are two types of accuracies. In the validation accuracy, what you do is you test your data, you train the data, you give a new example to it. So what exactly we do in validation is we divide the complete data set into three parts. So what exactly we do? If suppose this is my complete data set, like this. So generally what we do, 80% of the data goes for training, 10% will go for validation and 10% will go for testing. Or I can say 70% for this, 15 or 50 or whatsoever, whichever percentage you want to have, you can do that. So I train myself on this data. This is and in fact in your workshop also, you are giving major portion at the time of training only. You are studying, you are attending the lectures for 9 to 5 whatsoever. So you are doing the major portion of your time is spent in studying. Correct? So the major portion of your time is spent in studying. This is studying part. And this 10% you give a new data to this. This is a new data which I am not trained on. Because Shanti ma'am was asking questions to her which she may not have studied in the training period.